Welcome, everyone. Sridhar from Google and Chetan from Colt. And today we're going to talk about the evolution of NaaS 1.0, the current NaaS platform, from a digital experience using network APIs and NaaS LSO APIs and such, to an intent-driven, AI-powered customer experience that's built on intelligence, automation, and autonomy. That's really the focus of our talk here. So before we get into this journey and evolution, let's kind of focus on what our customers, specifically enterprise customers today, are looking for to be solved by their service providers. And they have a whole host of different asks, but if you kind of boil it down, it mostly falls into these buckets here that you see. So you got enterprise customers looking for enhancing their efficiencies in operating their networks, and that would obviously reduce their overall cost. That's the key driver there. And then you got enterprises looking for agility in the service delivery and assurance. So that is obviously talking about reducing the cycle time. You got some of them, most of them actually need their network to understand the context and the intent from an application and a business perspective. And that's really key, and that's really what we'll be focusing on in this evolution that we talk about. And then you got the enterprises looking for commercial models and flexibility, be that pay-as-you-go models or subscription models, bundling options, or different kinds of options in their terms of contracts and such. And then lastly, you got enterprises globally looking at ESG initiatives that kind of drives them towards solutions that are sustainable and also has the added benefit of reducing their operational cost as well. So those are really what most of the enterprise customers are looking for today. And if you look at NaaS 1.0, which is the current paradigm of what we have, what it has done is it successfully moved the industry towards a programmable network paradigm. And that's what you've heard in most of the conversations and discussions in the panels since morning today. And so what it has done is it drove automation across the different phases of the customer journey, from the design, delivery, and the operations of the network. So while this is good, while NaaS addresses most of the challenges that we pointed out in the previous slide, if not all of them, the key challenge or the issue there is that it requires a significant amount of effort from the enterprise side to leverage the automation that NaaS 1.0 provides. And an added complexity there is to hire the specialized staff that is needed to kind of put together this effort, right? And that's no mean task. And then there is no intelligence built today in the NaaS 1.0 paradigm that you would need for continuous learning and optimization of the network operations. So that would still require human intervention and a human in the loop, which again is costly. And then finally, you got to ensure that the network operates in an end-to-end secure manner gets extremely challenging in this new AI world where you got AI helping or AI enabling the bad actors as much as it helps the good ones. And then you got all these different new surfaces, attack surfaces available. So that's a key challenge that also NaaS 1.0 could do a better job of addressing. So what NaaS 2.0 does is it takes the NaaS 1.0 as a foundation and then adds the intelligence and the autonomy and of course leverages the automation that's already built in to create that outcome-driven experience. So with that, I will have Chetan walk us through the rest of the evolution journey here, and including a demo.
Yeah. Thanks, Sridhar. That's a great intro into NaaS 2.0. So I just want to explore further in terms of how do we see the evolution into NaaS 2.0. I think the foundation for NaaS 2.0 is Agentic AI. The reason is because with this new paradigm, what we want to deliver an outcome experience. For this outcome experience, what we expect the NaaS to have a continuous process of plan, act, and observe across the customer journeys. And this is possible only by having agents across the customer journey. For an agent to plan, it needs to capture an intent, and it needs a UI for that, just like a Gemini app. Once the agent has an intent, it needs to act, and for act, it needs tools. And one of the key tools over here is programmable network APIs. And once it's acted, it needs to observe so that the agent can continuously have a feedback loop in terms of what further refinement is needed. And this is where the network telemetry comes in the picture. So what we are saying in principle that an agents have to work in a continuous cycle of plan, act, and observe across the customer journey to deliver an outcome experience. Let's now see how does an outcome experience delivers value to the customers, addressing the customer challenges, what Sridhar shared. So I think one of the most common theme, if you see in this slide, is basically across the customer journey, you have an outcome experience across. So the yellow bubble is across all the stages of customer journey. So just to bring the parallels around, I think the design in the NaaS 2.0 is not about catalog-based selection, but it's more about making a request of an intent, making an intent request to an agent delivering you an optimized design, which aligns to the commercial and technical requirements of the customer. Provisioning is not about static workflows, it's more about dynamic workflows, where an agent autonomously works to fulfill an intent and ensures that the service has been delivered is compliant to the outcome. From an assurance and optimization perspective, it's all about not only about proactive, but it's all about predictive, self-healing networks, and not only taking into consideration the network context, but going beyond to understand the business context, the application context, and also the security context to provide that intent-driven end-to-end assurance. I think the learning is the key aspect of NaaS 2.0. Agents have a memory. As part of the memory, they have an understanding of the business context, the application context, the network context, the security context. And during the life cycle, they have gone through a lot of changes, and that helps up to build up that adaptive intelligence in a way. And this adaptive intelligence across the continuous life cycle process helps to ensure that it addresses the customer challenges over a period of time. I'd just like to walk through a kind of a demo, which it's kind of a prototype implementation focused on assurance and optimization. Before I do, I just want to set up the scenario over here. So the scenario over here, what we are seeing is like, imagine a stadium site connected to a Google Cloud platform. This is on a private connectivity. In this case, the private connectivity is called private access or dedicated cloud access. Now, above this network service, we imagine there's an application running. In this case, the application is a media broadcast stream going to the streaming servers hosted in Google Cloud. And then you have live audience subscribing to those streaming servers. Now this connectivity is crucial from a perspective of commercial, revenue, as well as the user experience, what you're going to deliver to the customer. So in order to enable that outcome, what will happen is that the stadium operator can define an outcome goal. The outcome goal is shown by the green blob on the right-hand side of the screen. I think, and that is mainly about high quality broadcast backhaul for seamless live streaming. Now, as part of that outcome goal being defined, the agents using the AI ML models will calculate an outcome experience score, which is a blend of application metrics and the network metrics. So we are going beyond the context now of basically combining what's the goal, what's the application metric, what's the network. So we are going beyond the network to calculate that abstract outcome experience score. Once we have that outcome experience score, the idea is to build an agentic closed loop automation which works on a plan, act, and observe cycle. And as part of that act, in terms of taking remedial actions, there are two ways of doing it. One is fully automated, where you basically, the agents make direct API calls to do the resolution, or it can be partial autonomous, where a human in loop is required to make a remedial actions. And a simple example can be, there's a commercial implications and someone has to sign it off before a bandwidth upgrade happens. So what I'm going to do is I'm going to walk through a kind of a demo which is we're working through, but it just gives a glimpse of visualizing how it will cover. So if you see on the screen, this is more of a prototype right now. It's work in progress as part of the Colt on-demand NaaS platform. What we see is a customer dashboard which is showing a service basically, and the service, as I described, is a stadium side connecting to a Google Cloud. Right now, it's just a connectivity. It does not have any construct of any outcome or any intent on it. So what we want to do is basically we want to define an outcome in this case. So the outcome, what we want to say is we have the service selected. What we say, we define the outcome name over here as video stream. And we describe the outcome over here, which is basically defining we need a highly, sorry, I just have to read through it. We just need a reliable broadcast backhaul network to ensure seamless end user streaming. Now, once we have done this, we select an application flow. In this case, the application flow is a video streaming. It's a preset of source and destination. Now, what happens as part of this, defining this, an outcome experience score is calculated, which takes into the application and the network metrics together to build up this abstract score. Once we have this, we then select how do we want to achieve an outcome SLA. So we've got two choices, fully autonomous or partial autonomous. For now, we will select the fully autonomous, where an agent will just go and remediate if it's needed. We save this, and this defines an intent on the service. Now, once you've defined the intent, what we'll do is we're going to simulate a kind of an anomaly to see that how an agent will work through it. So if you see right now, the service has been provisioned with 1 gig circuit. It's a video streaming is an intent, and it's fully autonomous from an SLA perspective. And then the customer experience score is 8.9, which is quite above the threshold, so the service is healthy. Now, for this demo, we're going to simulate a kind of an anomaly out over here. As we see, what happens is basically with that, the outcome experience score falls down. And this basically results in terms of bunch of agents getting kicked on over here. And these agents are pretty much orchestrated in a sequential order at this stage. So the first one is the network monitoring agent, which mainly sees that, okay, there is a kind of fall in the KPI. The diagnostic agent then works through to find out what is the cause for this fall to happen. And once the diagnostic agent confirms it, then the decision agent finds out what should be the right remediation action to resolve this. And as part of that, and once it has been remediated, and then the remediation agent remediates. Pretty much in this case, what we are saying, it makes a network API calls to fix it. And once the remediation has happened, it goes into the validation agent, which just validates how the service is back there. Now, if we go through this, we see that as part of this thing, the service has been upgraded to 2 gig kind of it, and the customer experience score has been recovered in that way. Just to finalize this, finish this demo, I would also like to change this, into a partial autonomous and show how the human in the loop comes in the picture over here. So as I do in a partial autonomous mode, the outcome experience score comes back to 8.9, which is defining the baseline, and the bandwidth is also back to 1 gig. We run a simulation back again over here. Now in this case, again, the outcome experience score goes down, and the agents fire in. Now, interestingly, what's happening over here at the remediation agent stops over here because a human in loop is required because we have defined the SLA as partially autonomous. And in this case, a remediation agent is triggered asking for a human to confirm, considering there will be an additional fee to upgrade to 2 gig. Once the human confirms that, basically, the service gets upgraded, and we'll see in a minute, I think it will just go back to 2 gig, and the outcome experience score goes back to the normal in that sense. The interesting thing is that all of this information from an agent perspective has been logged over here, when the action is needed and what. And this is one of the key aspects, to build a responsible AI framework to show that we have the auditability, and also the idea will be to build explainability as part of it. I'll hand over to Sridhar to conclude it on this. Can we get the screen moved on to the slides, please?
Okay, I'll have to make up for some time here. All right, so we looked at the demo, which is finally, I'm glad it worked. So as we saw, NaaS 2.0 has been mentioned before as well. NaaS 2.0, which is this evolution from 1.0 to an intent-driven customer outcome experience, 2.0 is what we call it, is a journey. And the good news is, as part of this journey, service providers have already deployed the current NaaS 1.0 platform that's been built on the Mplify API framework. And now the next part of the journey is to build the rest of the Agentic AI stack, extending the capabilities for NaaS 1.0. And it starts with building agents, and building agents could be building the agent or creating a wrapper around the existing APIs using MCP. Again, other folks have talked about that in the previous sessions, or other toolkits that are available to create a wrapper on the APIs to communicate with the agents. And then you got the A2A, agent-to-agent protocol, and other open standards like that to create a multi-agent system. So that's the next step. And then once you have these agents developed, then this architecture could be flexible, where if you have an enterprise customer that wants to leverage this stack as a service, as an out-of-the-box solution, the agents can then be orchestrated to deliver that customer-defined outcome. Or if you have a large enterprise that wants to develop their own AI ops, but just wants to leverage the agents that are built as part of the stack, that's possible too. So that's kind of the journey that we foresee going from 1.0 to 2.0. And if this was to happen, and if enterprises start adopting this framework, how would it look like? If you take a look at an example, and this could be even a large enterprise like Google's own enterprise network team. So if you look at what the enterprises would want, are typically asking for, is they want tighter control over all of the lifecycle elements of their network operations, right from the operations part of it, the delivery, and the assurance. And that can, again, mostly be done only with agents, especially, again, if you go back to the point that I made earlier, which is hiring qualified staff is getting very, very challenging to do all these other efforts. Right, so that's one reason why, one of the ways the customers could obviously deploy these agents. The other one is today, if you look at the enterprise network operations team, there's a lot of things that they need to be doing within the organizations, like they have access controls for the device, manage the access controls for the devices, they do software updates and a whole host of other things. Again, agents can clearly offload that piece of the function. And then if you add on top of that, cool technologies like digital twins, which are essentially near real-time duplication of the physical network itself or the topology of the network. These agents can do what-if analysis scenarios, for optimization and anomaly detection and such, and simulate before they roll the solution out or deploy the solution onto the physical network. And all of this can be done by the agents. And if you come to the design phase of these networks, today if you look at a typical enterprise network design lifecycle, it's a long journey. It's up to a 5-year journey, and that's because there's a whole host of things that need to get done, starting from business requirements to the product requirements, field trials, final commercials, implementation, and such. And also keep in mind that designing a network is not just about the hardware component of it. It's about designing around policies, compliance requirements, and a whole host of regulatory checks that need to be involved in the design phase as well. So once again, deploying agents will give the best shot to reduce this life cycle to less than 2 years, which is what most of the enterprise customers out there want to do. But the key here is the human in the loop. The human in the loop is still very much needed, but mostly for a supervisory role, right? So in terms of configuration, making sure the systems are operating at the optimal level that they need to be. But most of the day-to-day work, if you will, is handled by the agents. So the key takeaways, again, NaaS 2.0 is a journey. You've heard that over and over again since this morning. It's a journey towards an autonomous and intelligent platform with 1.0 laying the foundation and Agentic AI being the catalyst for this evolution or to make this evolution happen. And it's a paradigm shift to transform from a programmable network approach to deliver outcomes based on customer intent. And what this requires is a platform that abstracts away all of the underlying network and operational complexities. And then finally, it's about giving the flexibility to the enterprise customers by developing the appropriate stack where if you have a customer that wants to use the solution out of the box, they can do that. Or if you want a large enterprise wants to build their own AIOps platform, they can do that as well. We're way over time, and I think we're done.
Great. Thank you.
Thank you.